The Dirt with me, Mike Howell, an economics podcast where I present the down and dirty agronomic science to help grow crops and bottom lines. Inspired by eKonomics.com, farming's go-to informational resource, I'm here to break down the latest crop nutrition research, news, and issues, helping farmers make better business decisions through actionable insights. Let's dig in. Welcome back to The Dirt. I'm glad everybody's listening today as we continue our discussion on nitrogen with Dr. Hunter Frame, agronomist at Virginia Tech. Last time we talked about the importance of nitrogen, why it's needed in the plants, and the different forms of nitrogen. Dr. Frame briefly mentioned that we can lose nitrogen in several different ways. So today, Dr. Frame is joining us again to help us better understand these different loss pathways and what we can do to reduce or prevent this loss from happening. Dr. Frame, thanks for coming back today, and let's get to the dirt. Last week, you told us a little bit about losing nitrogen from the field. So can you start off today by telling us a little bit more about the ways that we could lose nitrogen?
Yeah, so we'll start at the method of application. So actually applying fertilizer, not even have to be fertilizer, it could be manure as well, because manure has urea, has ammonium, and has some nitrates in it as well. So let's take urea fertilizer, since that's becoming the dominant fertilizer worldwide. So when we apply urea to the soil surface, whether it's in UAN solution or granular urea, there's a little bit of difference there, because in UAN solutions, only 50% of the nitrogen is urea, compared to granular urea, 100% of the nitrogen is urea. So the first process that takes place is what we call urea hydrolysis. And this is a process that it's kind of near and dear to my heart, because I spent a lot of my career focusing on this one chemical reaction, urea hydrolysis. So what happens is that a urea is converted to ammonia or ammonium. And during that, there's a pH increase, because that reaction creates bicarbonate, which is then decomposed to water and CO2. But that bicarbonate increases the pH. And by increasing the pH, ammonium is then converted to ammonia gas. So NH4 plus at a zone of high pH is converted to NH3. And I know this is a lot of chemistry, but that ammonia is then lost to the atmosphere. And depending on soil type, soil characteristics, soil moisture, air temperature, and so forth, we've measured losses as high as 60% through ammonia volatilization from surface applied urea. So that means before the crop even can take up that nitrogen, up to 60% has been lost. So it means if you apply 100 pounds of nitrogen as urea, you can lose potentially under right environmental conditions about 60% of that, so 60 pounds. Now, that's in worst case scenario. Typically, it's going to be between the 10 and 30% range in field conditions. But we've saw here in Virginia on our low CEC, low buffering capacities, which means it doesn't resist pH change very well. We've seen corn yields at 240 pounds of N to the acre when we treat it with an inhibitor or a stabilizer. We've seen corn yields with a stabilized that protects against ammonia volatilization at 280 bushels per acre. And at the same nitrogen rates not protected, we've seen 192 bushels. Now that's an 88 bushel yield increase just by adding a stabilizer to control that chemical reaction. So that's urea hydrolysis. So we can lose a lot of nitrogen on our soils through that first chemical reaction with urea-based fertilizers. As we go through the nitrification, which is ammonium to nitrate reactions, once we get to nitrate, we can lose, if we're in the right conditions and we have high rainfall events and you have soils that have low CECs that are sandy, textured soils, we can leach nitrogen, which means nitrate will be carried away with water that is moving downward through the soil profile. And once that gets out of the rooting zone, that plant can no longer take it up. Or if the field's got drain tile, one of the things in the Midwest under a lot of tiled fields and in the Mid-South is we've artificially drained that soil better. And so that downward movement and that movement of water into the drain tile and out of the field with nitrate, we worry about nitrate leaching in that situation. And a lot of fields in the Midwest have drain tile in them. And then the other thing, if soils are saturated for a prolonged period, which means that they're waterlogged and they have anaerobic conditions, we will see that nitrate being denitrified. And in a perfect world, we want it to go all the way back to N2 gas through the denitrification process, but that doesn't always happen. A lot of times that process is stopped short at the NOx gases, the N2O, the NO2s, and the NO species, and those are lost to the environment as greenhouse gases. And so those are lost pathways. But the great thing is we have products on the market that are stabilized or controlled release products, but these products act on the bacteria that transform ammonium to nitrate. So we can stop that reaction and keep nitrogen in the ammonium form, which is held on cation exchange complexes in our soils, which allows the nitrogen, one, to be available to the plants in the form of ammonium, but also to be held on by soils a little bit better to prevent these different loss pathways. So there's technologies out there that allow our nitrogen to be managed to prevent these environmental losses.
Okay, Dr. Frame, you talked about volatilization and you could lose 60% of your nitrogen through volatilization. Do you have any estimates on leaching and denitrification? How much could we potentially lose through those processes?
I think, again, you could probably lose 10 to 30%. Depending on the environmental conditions present and the soil types that you have and how you apply the nitrogen. So one of the big concepts now prevalent across the industry is the 4R concept. So right placement, right timing, right rate, right source. So in our area, we have a lot of people injecting, subsurface injecting nitrogen. And so they're not going to lose a lot through ammonia volatilization, but they do on our sandy soils have the potential to lose it through leaching. So if we get these big thunderstorm rains that drop 5-6 inches of rain in 30 minutes or an hour, like we have been getting the past few years, you potentially could lose, 10 to 30% of your nitrogen through the bottom of the soil profile through leaching.
Right. Now, you mentioned a lot of growers are injecting that nitrogen now, and I don't know if it's the same way in your part of the world as it is here in the Delta, but it seems like a lot of times I see these fertilizer rigs running through the field. They've got it hooked to the oldest tractor in the field, pulling it as fast as a guy can pull it, trying to cover as many acres in a day as he can. And that fertilizer rig is sitting back there bouncing up and down. And sometimes it'll get that furrow closed up good, or sometimes it won't. If you're trying to do it in wet conditions, a little too wet, that furrow just doesn't seal at all. So it doesn't do any good to inject it if we're not going to slow down and take the time to make sure it is getting in the soil and that furrow is getting sealed up behind it. So, Dr. Frame, you kind of mentioned some of the inhibitors and stabilizers a little bit. Let's dive in now and talk about enhanced efficiency fertilizers, what we're talking about when we hear that term, and then we can go through some of these different products, the stabilizers, the inhibitors, and the controlled and slow release products.
Yeah, so when we talk about enhanced efficiency fertilizers and they're abbreviated EEFs, there's two primary categories, the stabilized products, and then they're the slow or controlled release products. Stabilized products have the characteristics that they actually work on the specific transformation processes that I described. So they work on urea hydrolysis as well as nitrification, depending on the products that are being used. And then the slow controlled release actually are your elemental sulfur urea, coated ureas. They're your polymer coated ureas. They're your low solubility products like the methylene ureas in those categories. So we'll start with the stabilized. Stabilized fertilizers are fertilizers that act on the transformations. So they act on urea hydrolysis or nitrification. So when we talk about these products, I would say haven't been widely accepted until about 8 to 10 years ago. They started becoming more and more accepted, but they probably were first labeled as snake oils, right? That, this is just somebody trying to sell me something because the chemistry wasn't, not from the scientific community, but from the grower community, the chemistry wasn't as well understood as it is today. But these products act at different stages of these transformations. So the first major category of products that I put in are the ammonia volatilization control products. And the primary active ingredient on the market now is the active ingredient NBPT. and that stands for N-butyl thiophosphoric triamide. Now that's a mouthful, so we just call it NBPT. This product is an inhibitor of the enzyme urease, which controls urea hydrolysis, and it slows down that chemical reaction basically. So by slowing down that chemical reaction, you don't have a buildup of bicarbonate, and by not having a buildup of bicarbonate, you minimize the pH spike, and by minimizing the pH spike, you keep the ammonium in ammonium-4, NH4+, instead of ammonia gas. The second group of nitrogen stabilizers are your nitrification inhibitors. And there's a couple different inhibitors on the market now, but the primary one that's been around probably for 20 to 30 years is the active ingredient Nitro Pyrin. Nitro Pyrin, it's actually labeled as a pesticide now because it kills the bacteria or it impacts the nitrifying bacteria. So it maintains the nitrogen in the ammonium form for a greater length of time. So typically we would see probably a 3 to 4 day window where you would see ammonium, and then those bacteria species would transform that under warm soil conditions to nitrate. The nitropyrin and the nitrification inhibitors keep that in ammonium form. So they keep that reaction. They work on the Nitrosomonas bacteria. The other actives are DCD that are on the market. And then there's the new one that came out a few years ago, and I think it's still being marketed under the trade name Centuro. So those are the stabilizers for nitrification that are currently on the market. And you can have different combinations of these actives. The biggest thing I tell growers is, like all products, there's an industry standard. And the way I compare it is kind of to herbicides, right? You have an industry standard Roundup formulation, which is Roundup. And then you have a lot of generics out there. But make sure the rate of active in these nitrogen stabilizers that you're applying is comparative to the industry standard. Like you wouldn't apply the brand name Roundup at 22 ounces to the acre if it has a certain concentration of AI, and then buy the generic that has a lower concentration of AI and apply it at a pint or 16 ounces, right? You want to make sure that your rate of AI is on point. The next classification of enhanced efficiency fertilizers are your slow controlled release. And probably the most common for row crop agriculture out there are your polymer coated ureas. And there's industry standards out there for that. ESN, environmentally smart nitrogen, that has been the industry standard for polymer coated urea. But there's other polymer coated ureas that have come on the market as well that are out there that can be used. And I really like the idea of these materials. They're a little bit more expensive because it does cost to coat the material, but these actually slow down the dissolution of granular urea. And basically, I think of a polymer-coated urea as a microscopic wiffle ball, like one of those wiffle golf balls that have holes all around it. And you need water to move in and out of those pores to dissolve the urea, but we can change the size of those holes. So we can actually get a prescription-based release based off of the size of those holes, the soil moisture available, and the temperature. And so all of those play a factor in releasing the nitrogen over a period of weeks. And what the idea behind this is, by slowly releasing that nitrogen, we allow crop uptake to be maximized and minimizing environmental losses of nitrogen. Then you have your sulfur-coated ureas, or your sulfur-coated fertilizers that actually use a physical barrier of elemental sulfur that needs to be weathered and degraded. But once that physical barrier has micro holes in it, those slowly release that nitrogen over a period of time, and the thickness of that coating is going to dictate how fast that product releases. So those are your slow controlled release. You have some products that are used in specialty fertilizers like your methylene ureas that affect the solubility. So the fertilizer isn't as soluble in water. And basically you have to have something pulling the fertilizer concentration out of solution for more to become available in the low solubility fertilizers. So those are the two categories of EEFs that we have to protect against environmental losses and to increase crop uptake.
Okay, Dr. Frame, you talked about these products, and they're all going to cost a little bit more money for the grower to use, but these products have been proven, and they're going to protect that nitrogen, keep it in the field, and convert that into yield that's going to affect the grower's bottom line. So great job of going through these. Dr. Frame, we've talked in some previous episodes about the price of fertilizers these days. We all know what's going on with that, especially nitrogen. It's really gone up a good bit over last year, 2 to 3 times the cost of application for last year. What are y'all doing in Virginia? Are you making any recommendation changes, changing the timing of application? I'm hearing some growers thinking about, instead of side dressing with the added cost of diesel fuel these days, maybe we can make one application and try to make that work. What are y'all thinking in Virginia this year? Any changes?
So, yeah, I mean, I wouldn't call them big changes. In our soil systems here in Virginia, we like multiple application systems. So we usually put 20 to 30% of our nitrogen out at planting, whether it's corn or cotton, and then we come back with a single side dress application. I don't know if I would recommend splitting your side dress in this year or not, because our research, especially on cotton, has shown we don't get a real huge yield benefit by splitting side dress applications. I would caution, especially on cotton, our guys to go to a more liquid system. We see about a 10 to 20% yield gain with UAN solutions compared to a granular system, but that's comparing reference materials. So that's not comparing stabilized urea. That's comparing granular urea to UAN solutions without any of these EEFs involved. If I was using a granular system this year, I would definitely encourage a producer to put a stabilizer on it, depending on their method of application and their placement of that. And I think that's going to be money well spent for insurance purposes this year. I can say that our data has shown that putting a polymer-coated urea out in one shot at planting in Virginia on cotton has performed very well compared to split applications. So if they did want to cut a trip across the field, I would definitely recommend going with a polymer-coated product. If you're going to put all your nitrogen out front, you definitely don't want to go with just a plain granular urea UAN solution. In our environment, you would want to use a slow controlled release. But as far as rates are concerned, when you do the economics, the one thing we have going for us across the board for nutrient management this year is we have high commodity prices. So if we were in a year where we were looking at $3, $4 corn and looking at $1.10 per pound of nitrogen, if you're talking UAN solutions, I think urea is a little bit cheaper at like 93 cent, 97 cent right now, looking at fertilizer prices. But the good thing is we're going to be selling $7, $7.50 corn. This morning I checked December futures on cotton, and I think you can get a December contract on cotton at $1.07 per pound of lint, which is for our guys. I mean, that's great. And so I would say, we really have to be mindful if we really want to cut back on our rates, because we still want to maximize yield. And we have the commodity prices to more than break even and still have a profit, even though our input costs have risen. What I worry about it, and this is not as much in terms of nitrogen as it is phosphorus and potassium, and I know that's not what this talk is on, is that our guys rely on what's in the soil this year and mine the soils. And then next year we get into a situation where we do have $4 corn, we do have 75-cent cotton, but yet we're still paying $1 per pound of nitrogen, and we're 60 some cents per pound of potassium. And now you've mined for a year, and now you have to, build those soil tests back up potentially. What do we do then? And so this year, I would say, given commodity prices and being able to forward price, I would say hold steady with your fertility practices this year. And then if commodity prices fall in 2023 or beyond and fertilizer prices stay high, then we got to get creative.
Right. We got to take it one year at a time. We don't have any idea what's going to happen down the road. So I really agree with what you're saying. We don't need to mine that soil this year. Make sure we make a good crop while we've got good prices to go with it. So, Dr. Frame, we've talked an awful lot about nitrogen and nitrogen management today. Is there anything that we've missed that you think it's important for growers to know about?
No, other than just a caveat, I do work a lot in the coastal plains. So a lot of my experience has been in coastal plain soil. So things change. And I would just recommend that you consult your extension professionals, but also your agronomists with your retailers. I mean, one thing that folks need to know is that industry as a whole have very good agronomists within industry that work for these retail companies that are providing recommendations as well. And hopefully in every state, your university extension people work with the retailers and work with these agronomists. I know I try to, listen to the recommendations. It's not a one size fit all, and also know your options. When it comes to sources, know your options and know what's available in your area and what may be most economical. Because, if you're a 5,000 acre farm, operation, and you're looking at, say, in the Mid-South, you might have 1,200 acres of corn and 1,500 acres of cotton, and your price of nitrogen Well, if UAN's $1.10 per unit versus granular urea is 97 cents, that may not seem like a big difference, but that 10, 13 cent savings over those 2,700 acres could work out to a substantial return.
It adds up in a hurry.
And so, know your options, know what's available to you, and don't be afraid to do something that maybe you haven't done in the past.
I do want to put another plug in for the university researchers and extension specialists like yourself. You mentioned the snake oils and how some of these products were considered snake oils years ago. The university system is one of your best resources for a grower to determine if these new products are really legitimate or if they are in that snake oil bucket. So I encourage you to get to know your extension specialist and go through the research with them. Ask questions and you'll be able to get better answers on these types of questions. Dr. Frame, thanks again for being with us today. Over the last 2 weeks, we've talked a lot about nitrogen, why we need it, the different forms of nitrogen, how it can be lost, and ways to protect it. Nitrogen fertilizer is a vital part of production agriculture, and without it, we wouldn't be able to achieve the crop yields that we need to feed this growing world population. But it's also important that we understand about nitrogen loss and the negative impacts of this loss. It can be bad for the environment and cause problems for other organisms that live here, and if we don't effectively manage it in our fields. It can cost producers money directly from losing up to 50% or more of their nitrogen fertilizer if it's not properly managed, and indirectly from reducing crop yields and revenue. I hope you've learned more about nitrogen and nitrogen management over the past 2 weeks. And if you want more information, please visit our website at www.nutrien-eKonomics.com. Listeners, thanks again for joining us, and please remember to share this podcast with others and leave your feedback in the comments section. Join us again next week when we visit with Chris Reynolds, Vice President of Sales with Nutrien. Until then, this has been Mike Howell with The Dirt.